Hello and welcome to, let's see. Yep. Welcome to our last video together. Um, this is my last video, lesson 8.3, the bungee jump simulator. Okay. Um, yeah, I mean it's kind of been full circle. Um, at least for you, right? Um, we're finishing up our final homework with me, Mr. Pena. Okay, so let's dive into it. Get it? Because bungee jump. So evaluate each function as indicated, state undefined when applicable. Okay, so we have a function here, right? This is my function, and we should be familiar with if there's an f of 0, right? This means that this is my x. So then f of 0 is equal to 0 squared minus 8 times 0, which is just equal to 0. Okay. We have negative 10 now, so that becomes my x. So negative 10 squared minus 8 times negative 10 is equal to, this is 100 minus negative 80. So this is equal to 180. Good. Here we have, oh, there's already an equal sign. Why am I putting it twice? 8 squared minus 8 times 8 is equal to 64 minus 64 equals to 0. Okay, this is 0, this is 180, this is 0. Okay, now we have something different. So now we have x plus 1. So are we going to be scared of this? No, we're not, right? So again, this is my x variable. So wherever I see an x, I'm going to plug in what? Yes, you're going to plug in x plus 1. Okay, so here we go. We have x plus 1 squared minus 8 times x plus 1. Very good. So then let's expand this out. This is going to be x squared plus 2x plus 1 minus 8x minus 8. This is equal to x squared. We can combine these like terms here. So we are going to get minus 6x. We have plus 1 minus 8 minus 7. Okay, let's go. Number two. Okay, so it is important to know that none of these were undefined, right? Because why? Because my domain here is just negative infinity to positive infinity. Okay, very good. Now, same concept, we have a different function g, and this is what it's defined, 3x minus 5 over x, and we're trying to figure out what g of negative 1 is. So let's plug in negative 1 in for x minus 5 over negative 1 is equal to negative 3 minus 5 over negative 1, which is equal to negative 8 over negative 1, which is equal to just positive 8. Very good. Okay. Oop, let's talk about this one. So then we have 3 times 0 minus 5 all over 0, negative 5 over 0. This is equal to absolutely nothing, right? We cannot divide by 0. So then does not exist, or as they called it, undefined. Undefined. Okay? We cannot divide by 0. Good. Now we have 1/3. So then we have 3 times, that's a horrible parentheses, 1/3. Oh my goodness, what am I doing? Minus 5 all over 1/3. So 3 times 1/3, it should just be 1 minus 5 over 1/3 equals to negative 4 over 1/3. Okay. Now we can't forget how to divide fractions. So let's show some work here just in case we did. Dividing it by 1/3 is the same thing as multiplying by 3 over 1, right? Then we get, this is negative 12, negative 12. Okay. And then last but not least, we're plugging in x plus 1 in for x, right? So we're going to have 3x plus 1 minus 5 all over x plus 1, okay? So let's kind of distribute this out. We're going to get 3x plus 3 parentheses, right? Let's just keep it there. Well, you don't have to. Minus 5 all over x plus 1. We can combine some like terms. So then 3 minus 5 becomes minus 2 all over x plus 1. Very, very nice. So we have 8 here. This is undefined. We have negative 12 over here, and we have 3x minus 2 over x plus 1. Okay? Okay, now we're talking about some trigonometric functions. So we have sine of x. Okay, so this is equal to sine of pi. Okay, we should be familiar with that. Okay, this is equal to just 0. Okay, and if you have trouble kind of picturing that or understanding why, it all goes back to our handy dandy unit circle. Yep. So again, at pi, we are here. So this is pi, right? So then at pi, sine is just 0, right? We have that this is negative 1 comma 0. So sine of that is just 0. Okay. Now we're talking about sine of 3 pi over 2. And let me kind of bring down this again. Let's copy this and let's paste it right here. I want to do perfect. Okay. What is happening? Oh my goodness. What am I doing? Oh my goodness. What is wrong with me today? Okay. So let's just kind of redo this again. Copy. I'm gonna paste the image actually. I'm gonna do that. So now if I'm talking about sine of 3 pi over 2, where is that on my unit circle? That is right here, right? This is 3 pi over 2. So sine of that is just equal to negative 1. Okay? This is negative 1. We're talking about 11 pi over 6. This is sine of 11 pi over 6 equals. So that is right here. Okay? So what is sine there? It's negative 1/2. Okay? Now 5 pi over 4, we are going to be talking about right here. This is 11 pi over 6. This is 5 pi over 4. So right there, this is sine of 5 pi over 4, which is equal to negative square root 2 over 2. Okay? Now for those problems, we can go ahead and use your calculator to just double check. I'm not entirely sure if you will have a calculator for some of these problems. You should be able to do them without a calculator. But if, for example, if I have sine, what's important? I need to make sure I'm in radians, right? So radians is good. I'm talking about sine of 11 pi over 6. So 11 pi over 6 is negative 1/2. That's correct, right? And then we have sine of 5 pi over 4. That is negative 0.707, right? We don't want that. We want an exact answer. And if you double check your answer, you have negative square root of 2 all over 2. We get that is correct, right? So very, 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 very nice. Last but not least, talking about tangent. So let's talk about this is equal to tangent of pi. So what is that going to be? So again, let's draw our unit circle. Okay, so pretend that that's a perfect unit circle. So at pi, this is a negative 1, 0. So then tangent of that is 0 over negative 1, which is equal to 0. Very nice. Now here we have tangent of 3 pi over 2. So at 3 pi over 2, we're over here. So this is 0, negative 1. So then tangent is y over x, so negative 1 over 0. And this is equal to what? This is undefined. Undefined. Okay? And I should have highlighted these. So this is 0. This is negative 1. This is negative 1/2. Negative square root 2 over 2. This is 0. This is undefined. Okay, now we're talking about tangent of 7 pi over 6. Okay, let's kind of figure out what 7 pi over 6 is. So we know that this is 6 pi over 6, which is just pi. So 7 pi over 6 is right there. 7 pi over 6. Now, what's the coordinate point for 7 pi over 6? I'll put this inside. The coordinate point there has to be a negative and a negative, right? But negative what exactly? So we are farther on the x-axis, so this has to be negative square root 3 over 2, comma, negative 1/2, right? Um, Now tangent is going to be negative 1/2 over negative square root 3 over 2, right? So you can't forget how to divide fractions, right? So is equal to, let's show our work, negative 1/2 dividing it by, so we can just times 2 over negative square root 3. So this is just going to be equal to 1 over square root 3, which is equal to what? Square root 3 over 3. Okay, so we should be able to rationalize this square root here. Okay. Now tangent of 3 pi over 4. So for that, we're talking about this is 1 pi over 4, 2 pi over 4, 3 pi over 4. So that's right over here. And what do we have? We have negative square root 2 over 2, comma, square root 2 over 2. So that's going to be square root 2 over 2 divided by negative square root 2 over 2, which is just going to be equal to negative 1. Okay? Because these are the exact same thing. We're dividing the exact same thing. Negative 1. Okay, very, very nice. Let's go to 5. So now we have two functions are graphed. Graph a third function by multiplying the two functions together. Okay. You may want to use a table of values to assist you. Displaying out the table is optional. Nope, it's mandatory. After you have graphed y3, graph the line y4 equals negative x. Okay, let's kind of take this step by step. So y1 is graphed for us, and let's kind of just substitute in our values there. So this is negative 2 pi. This is negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and then 2 pi. That's this line right here. And then sine of x. So let's kind of go through that motion. This is 0. Sine of negative 3 pi over 2 is 1, because once you talk about the unit circle, negative 3 pi over 2 is where we are over here, right? So that's positive 1. This is still 0. And then we have negative 1, because now we're talking about this point right there. And at 0, we are at 0 again. And now at pi over 2, this goes back to the ones we know and love, on negative 1 and 0. Okay? So these are those. And now we've done y1 with y2. Those are graphed. So what about y3? So y3, we are multiplying the two functions together. So let's multiply y1, essentially y3 is equal to y1 times y2, right? So we're multiplying these two. So then the first one is just going to be 0. Here we get negative 3 pi over 2. This is 0. Now we get positive pi over 2. This is 0. This is pi over 2, positive. And then we have 0 again. And we have negative 3 pi over 2. And then we have 0. Okay? So then let's kind of graph those. But to do that, we kind of need to figure out our decimal approximations for these. So let's quickly go to our calculator. Let's go. So right here we have a negative 3 pi over 2. That is negative 4.71. So negative 4.71. Okay. Then pi over 2, that is 1.57. So this is equal to 1.57. This one's also 1.57. And then we're back to this other one that we already know is negative 4.71. Okay, so those are our values for y3. And now let's graph those. Let's graph those points. So let's try our best. So I'm going to put them in blue. So at negative 2 pi, we are at 0. Okay. At negative pi, we are at 0. So let's just kind of put those zeros first. 0. At pi, we are at 0. And then at 2 pi, we are at 0. Okay. Now let's graph it. Negative 3 pi over 2. So negative 3 pi over 2 is right there, right in the middle. We're talking about negative 4.71. So that is going to be, this is negative 3 pi over 2. And let's put that somewhere here. Somewhere here. Yeah, negative 4.71. Because these are going by 2, so that seems about right. At pi over 2, negative pi over 2. So that's right here. We are at 1.57. So maybe something like between, maybe something like here, question mark. So I'm trying my best to kind of graph these. And then at pi over 2, we are at the same point. So pi over 2 would be somewhere here. Okay, so maybe like there. And then at 3 pi over 2, we are back to the negative. So we're back over here. Okay, so let's kind of connect those points. Here, here. Wait, am I missing a point? No, I'm not. Here, 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 here. Okay, so that doesn't look as pretty as I thought it was going to be, which is totally fine. But now let's kind of graph this in our expert graphing calculator, right? Well, not of that. Well, yeah, sure. So let's clear those up. And then here we're supposed to have x times sine of x. Okay, let's graph this. Oops, look at that. And so our graph should be something between negative 2 pi and 2 pi. So you can change your window here and go to negative 2 pi up into just positive 2 pi. Our y coordinate goes from like negative, let's do negative 6 up into 6. So something like that. So my graph looks a little bit choppy, I would say. Um, but I think you hopefully get that that's kind of what it should look like. And then what is next? After you graph y3, you got the line y4 equals negative x. I'm going to use a different color for that. So negative x, so y4 is negative x. That means that my slope has to be 1, my slope of 1, and my coordinate units here are not the best. So I'm gonna struggle a little bit graphing this. I don't know why they gave us something like this. Um, so yeah, let's just try my best. So 2's here. Um, I need to put more points. And at 3, right before, I'm like gonna be like somewhere there. At 0, I'm at 0. At 1, I'm gonna be like at 1 here. And then at 2, 1, 2, I'll be like here. And then at 3, I'm gonna be like, oh, no, that's a little too, like 2 there. 3 would be somewhere here. So just something like this, I would say. This isn't the best line, if I'm being honest. But something like that. Um, and let's kind of go ahead and maybe see this better on an actual calculator. So let's go to y equals and let's graph negative x there. Okay, so what do we kind of see? Um, Interesting graph. So what do you notice about the graph of y3, which is the one we drew, the blue one, um, in relation to the graphs of y1 and y4? So let's also graph y1. So this is just x. So what do we see there? So like y3 is this blue one here. What do you see just from this perspective? Maybe we can zoom out. If we zoom out, what do we see? Let's change the window a bit. And let's do like 50. So what, and let's change our Y. Let's change our window here. So let's go to like 50 as well, let's just say. So what do you see? Isn't this so cool? That like, you know what I mean? Like these lines, the y equals x and y equals negative x are the what? Your function y3 is always in between what? It's always in between them, right? So that's so cool actually. So y3 is bounded by y1 and y4. I think that's phenomenal. Um yeah, that's what you can say. Cool. Okay. So you saw me working on stuff earlier. Okay. Okay, cool. So now let's go to the go section. Excuse me. What color have I not used? I've used a lot of these colors. Okay. So we're going to express each exponential equation as a log. So we should be a little familiar with this. So let me kind of just do a recap of how it should look like. So recap, if I have base b to the x equals y, let's talk about this as a log. It would be log of base b of y equals x. Okay, so here I have that this is my base 8. So this is going to be log of what base? Base 8 of 512 equals 3. Okay, so this is what we're looking for. Let's use a different one. Okay, so now let's kind of go to number 7. Log of what base? Base 5 of 1 over 125 is equal to negative 3. Okay, this is totally acceptable. Cool. Log of base 4, this is base 4, of 1 over 16 equals to negative 2. Number 9. Okay, so what do we see? There's something different. There's a base of pi. Totally fine. So log of pi of 1 over pi is equal to negative 1. Okay, very nice. For number 10, we have this is my base. So we have log of base 10 of what? 1000 is equal to 3. Now, very important to note that if it's a log of base 10, we usually don't write the 10, so we can just write this as log of 1000 is equal to 3. Good. Number 11, so another base 10. Log, are we going to be scared because there's just a bunch of variables? No, we're not. So log of h, well, let's do log base 10, just so we can know that, equals b. And now again, like I said, you don't have to write that with 10. So log of just h equals to b. Okay? This is kind of what I would want you to write it as. Number 12, so base e, so that should ring some bells, right? Because there's a special way to write a log base e. We'll talk about that right now. We have log of base e of m is equal to a. Okay? Now we should kind of think about this. Log of e of x is equal to what? Ln of x, right? So then here we can write this as ln of m equals a. Okay? And this is how you should write it. These two are equivalent statements, but the importance of e cannot go unnoticed, okay? Let's talk about 13. So again, we have e to the x equals 17. So what's your base? My base is e, so log of e of 17 equals x, okay? Now it's important to note, again, we have a base e, so this is ln of 17 equals x. Very nice. And then last but not least, what's my base here? My base is a variable, which is totally fine. Do not be scared. Log base x of e equals pi. Okay, this is totally fine. This can be your final answer. Perfect. So I hope that was not too difficult, and that it made some sense. Please come to office hours if you have any questions, comments, or concerns, okay? And this is our last video, so I hope you had a great and fantastic Math 3 school year, okay? Have a great day.